All right, second part. Which graph can be obtained by translating the quadratic function y equals 0.28x squared minus 4 up 7? So right now it's here. They're telling you that first it's at the minus 4. Notice it doesn't have parentheses, so there is no right or left shifts. They're telling you they took this one that was already at a negative 4. Sometimes I like to draw it. 1, 2, 3, 4. First it was here at negative 4. Then they took it and moved it up 7. So they went up 1, 2, 3, 4, 5, 6, 7. So it should be right here now, which looks like this one here is the only one that's up at a 3. Any questions? A section of the graph of a quadratic function is shown. Which of the following points is also a part of the function? So if we're looking at this quadratic here, there's a couple different ways. You can try finishing it, or you can plot this point 2, 7 and see if it looks like it's a part of the graph. So I'm not sure. 2, 1, 2, 3, 4, 5, 6, 7.
No.
If you put that, to me that doesn't look like it because the axis of symmetry is right here, so it's kind of like it's not spaced evenly, so that's not good. 4, 7. 1, 2, 3, 4, then up 1, 2, 3, 4, 5, 6, 7. This one looks pretty good. Let me just make sure if it's 1, 2, 3, 4 spaces from the axis of symmetry here, then it's 1, 2, 3, 4 there. So it looks like it's B. 0, 3. 0, 3 is right here in the middle of the graph. No, not going to be that. And then 4, up 10, that would be too high. So just be careful with this one. Plot the points and see what's going to complete the rest of the graph. A scatter plot below shows the relationship between the side lengths of each square and its area. Which of the following is the closest to the side length of a square with an area of 55 square units? So they're asking about the side length, so they're asking about this for something with an area of 55 square units. So look for 55 over here. 55 would be in between 50 and 60. So according to this graph, it looks like it would be somewhere between, notice that dot was missing. I just put it there. It's between 7 and 8 somewhere. Oh, this one's really close. I would go 7.5, I guess. Yeah. 7.5 for that one. That one's really close. Because they put a 7, an 8, then a 7.5. So it has to be between it. What is the y-intercept of the following graph, and what is the range? The y-intercept is where it touches the y-axis. Problem is, yes, it's at -6, but does that mean it's -6, 0 or 0, -6? Good. Make sure you understand this is a y-intercept. The range, range, once again, they're talking about y's. So the lowest part of the graph is at -6. The highest part, no, there is no highest part because the arrows mean it goes on forever. So this one would be all of the y values that are greater than or equal to -6. Because it points up. This opens up. When it opens up, that means its y is greater than or equal to. If it opens down, that means its y is less than or equal to. If it had the little open and close circles, then you need to refer back to the problem on the front that looked like that. Which graph best represents a function with a range of all real numbers less than or equal to 6? We just talked about that. If its y is less than or equal to something, that means your graph needs to open down. So this one opens up, that means it should not be less than or equal to. This one opens up, it cannot be less than or equal to. It has to be one of these. And we're looking for the range, which means the y value is less than or equal to -6. So which one is that? C. Good. This shows the y value of -6. So it's C. This shows the x value of -6. So that's not going to help us with the range. What is the range of this? In order to find the range, I keep saying you need to know the vertex. So you can use the calculator to find the vertex. Let's do it. I'm going to go ahead and clear my calculator because these numbers look funny. So second plus 712. And my y equals, I'm going to put, what is that, a subtraction or a negative? That's a negative because it's in the front of the equation. That needs to be a negative. So press second graph. Start looking, oh, this is perfect because it already gives me my symmetrical pairs. Symmetrical pairs. So in the middle of my symmetrical pairs, I will find my vertex. We're finding the vertex in the middle of the symmetrical pair, so that's 3, 18. Now that I know the vertex, I know my y value has to help me figure it out. How do I know if it's less than or equal to or greater than or equal to?
It opens down.
Yeah, some people can tell by this negative, that means a parabola opens down. Another way to check is to look at your numbers around the vertex. They're getting smaller. Or even press graph. Hopefully it shows it. Yes, it opens down. So that should be less than or equal to. If the quadratic function y equals x squared is shifted so that its vertex is 6, 1, which equation best represents the new function? They're basing this one once again. Okay, good. I'm glad y'all got some answers. Let me just tell the people that are watching. They're basing it off vertex form. It's the opposite of the h, the same exact k. Opposite h, same k. So h was 6. That means if I'm putting it in my equation, it better be a minus or a negative 6. And the same exact k, which should be a plus 1. Yep. So B. How would the graph of the function y equals x squared be affected if the function were changed to a half x squared? Remember the a in the front of the x squared or the a in front of the parentheses, that's going to either make it have a vertical stretch or a vertical compress. Stretch means skinny. Compress means wide. Stretch means the numbers are getting bigger. So be careful. Stretch means the number is bigger than 1 or getting bigger and bigger and bigger. That's the more stretched. Compress would be it's wider, which means the number is a smaller number, or something that's smaller would be wider. So be careful. This one, and it's not going to do any shifting because shifting is when you're adding or subtracting. This one's A is getting multiplied, so it looks like it's B for that one. The graph of f of x squared is transformed to create this graph of g of x equals a third f of x. This is kind of very similar to this one because first it was x squared, now it's a third of f of x, which is x squared. Which graph best represents the functions f and g? So which one should be wider? G should be the one that, thank you, the second one should be wider. So we're looking for G to be wider. On this one, G is, it looks like it's narrow, but I think it's actually the same. So this one, G is the same, it's just moved up 3. Did it say anything about shifting it up?
No.
No. All it says is it got vertically compressed. This one here, that's the answer, because this one is where G got more narrow. This one, G got wider. All right. One more thing I want to add here is this review didn't talk about any roots. So let's talk about some roots because I really believe roots is on your test. It better be as much as we talked about it.
Don't you have it?
Yes, I do, but I haven't really looked at it yet. So, yeah, so look at 13. Notice I have 2 roots, also known as zeros, also known as x-intercepts. So this root is at what? -2, 0. And this root right here is the one that's between, because we were writing that on the assessment yesterday, between 1 and 2, which we could say is maybe about 1.5 or 1.6 somewhere. Okay? So please understand, make sure you remember what a root is. And if there's one located in between, you remember what in between means. Because that's kind of weird that there's no, that's funny. Okay. Once again, look here. Which one of these graphs has no roots? D, you're saying it has no roots? It does not touch the x? Be careful. C is the only one that has no roots. Thank you. C, I'm just going to add that. No roots. Just so you can understand, a root is where it touches the x-axis. So this one has no roots. This one only has one root because it touches once. This one has one root, it touches once. This one has two roots. Okay? So please make sure you understand what a root is. And also, this root, is this a positive or a negative root?
Negative.
This is a negative root. What about this one? Positive or negative? This one?
No, negative.
This root where it touches the x-axis, that's a negative root. So be careful. Yeah, be careful. This one here, what does this have? Does it have two roots that are negative?
No.
No. This root's negative and this root is positive. All right? So please understand, that's just extra information for the test.